Hello, these are the notes for topic 9-2, operations with radical expressions. So, we're going to talk a little bit about simplifying radicals like we did with 9-1. However, we're going to add some division. And so I want you to know that if I take the nth root of a divided by the nth root of b, is the same as the nth root of a divided by b. These are interchangeable, and I can go back and forth depending on which one helps me to simplify the expression. So, let's go ahead and look at this. Well, I can go ahead and replace this with the cube root of 48 over 2, which 48 divided by 2 makes 24. So this is the cube root of 24. Now that I've got it fairly simple, I'm going to break it down. Well, now 24 is 2 and 12. 12 is 2 and 6, and 6 is 2 and 3. And so my index is 3, so that means I'm looking for groups of 3. Got 3 2's right there. This 3 is left behind. And so what I have here is 2 on the cube root of 3. Let's go ahead and look at number 2. Well, number 2 is a little bit different. I can't do 27 divided by 8. It doesn't help me. So I'm actually going to break this out the other way. Let's say the cube root of 27 over the cube root of 8. And so I need to do this twice. So if I look at 27, 27 is 3 times 9, which is 3 times 3. Got a pair of 3's. And so the cube root of 27 happens to equal 3. Now if I do the cube root of 8, this is 2 and 4, which is 2 and 2. Got a group of 2's, so that equals 2. So what this comes out to is the cube root of 27 was on top, so 3 is on top. Cube root of 8 is on bottom, so 2 is on bottom. And I get the fraction 3 over 2. So as you can see, sometimes we want to put them into a single form if we can divide and get a smaller number. Other times we want to break into 2 pieces so that we can solve each and get a fraction. Let's go ahead and take a look at number 3. Well, the square root of 3, I know, is just going to be 3. So I'm going to leave that alone for right now. I'm going to look into what the square root of 18 is, because that just stays the same. Well, 18 is 2 times 9, and 9 is 3 times 3. And it's the square root, so I go ahead and pull these 3's out. The 2 is left behind. So let's see what I've got. I've got the square root of 3 on top of 3 on the square root of 2. Now, this is not fully simplified yet, because one thing I want to tell you is that we do not want to see radicals in the bottom. So to get rid of it, I'm going to multiply by the square root of 2 over the square root of 2, which anything divided by itself is 1, so I'm really multiplying by a fancy version of 1. So let's see what I get. Square root of 3 times the square root of 2 is the square root of 6, which if I try to break it down is 3 and 2, so 6 stays, over, well, 3 and the square root of 2 times the square root of 2 is the same as 3 times 2, which is 6. And so this is where we are done. Just to go over this again, the square root of 3 wouldn't change, so I left it be, and I focused on the square root of 18, which I solved, got 3 on the square root of 2. Now, because I can't have a radical on the bottom of a fraction, I can't have it in the denominator, I multiplied by that radical on top and bottom in order to get rid of it. Those gave me the square root of 6, and these gave me just regular 6, not the square root. Because the square root of 2 times the square root of 2 is 2. Let's go ahead and move on to number 4. Well, we've got the square root of 8 over 20. Well, I'm looking at this and I noticed that I can simplify 8 over 20, and neither of those are a perfect square. So let's go ahead and simplify this. That equals the square root of 4 over 10, which can be simplified even further to 2 over 5. All right, well, now let's see what we have. Well, that's the square root of 2 over the square root of 5. And I can't have a radical on the bottom. So I'm going to multiply this by the square root of 5 over the square root of 5. Well, let's see. Well, 2 times 5 is 10. So that gives me the square root of 10 over the square root of 5 times the square root of 5 just gives us a regular 5. And if I were to try to simplify, the square root of 10 is just 2 and 5, so it won't simplify. That is as far as we can go. So again, I took the fraction, I simplified to a new fraction, then I split it up and got rid of the radical in the denominator by multiplying by it on top and bottom. That's just a fancy way of multiplying by 1, and got my answer. Now let's take a look at number 5. Well, square root of 3, that's pretty solid. I can't mess with it. Let's go ahead and figure out the square root of 72. Well, know that 72 is 9 times 8. 9 is 3 times 3. 8 is 4 times 2. And 4 is 2 times 2. So I've got a pair of 3's, a pair of 2's, and a lonely 2. So this equals 3 times 2 on the square root of 2, which is 6 on the square root of 2. And come back over, have the square root of 3 on bottom, so we can't forget about it. And again, I can't have a radical on the bottom, so I'm going to go ahead and multiply square root of 3 over the square root of 3, which 2 times 3 gives me 6. So I've got 6 on the square root of 6 over, well, 3 times 3 makes 9. The square root of 9 happens to be just regular 3. Again, the square root of 3 times the square root of 3 is regular 3. But I can simplify this a little bit further. 6 divided by 3 is 2 on the square root of 6. Again, couldn't mess with this, so I went ahead and figured out 72. Got 6 on the square root of 2. Brought back my square root of 3. Got rid of it by multiplying by a square root of 3 over square root of 3. Gave me 6 on the square root of 6 over 3. 6 divided by 3 makes 2. So it becomes 2 on the square root of 6. Let's go ahead and look at number 6. Well, I can't do any kind of simplifying right here, but I do need to go ahead and get rid of that square root of 10. Remember earlier, up here, we said that square root of 10 was the simplest it's going to get, so there was no point in me messing with it. Eventually, as you practice these, you'll learn which ones you can mess with and which ones you can't. At least you'll get a better idea. So let's see what this brings us. Well, 2 times the square root of 10 is just 2 square root of 10 over the square root of 10 times the square root of 10 is a regular 10. And 2 over 10 will simplify to 1 over 5. And we don't actually need to write the 1, so we can just put that this is the square root of 10 over 5. Well, I've just gone over 6 examples working out how to simplify each of these radicals. Let's go and go to the next page and see what awaits us there. All right. Here we're going to talk about adding radicals. But we can only do that if the index and radicand are the same. Let's take a look at this. I'm looking at these. My indexes, they're both not there, which means they're both 2's. So they're the same. Check. Now the radicands, they're both 3. So basically this is the same as 2x plus 3x, but instead of x, they've given us the square root of 3. So 2 plus 3 makes 5 on the square root of 3. That one was very simple. Let's go ahead and take a look at number 8. Not quite as simple. First, we need to go ahead and simplify each of our radicals. So look at 50. That is 5 times 10, which is 5 times 2. Pair of 5s, 2 left over. This becomes 2 times 5 on the square root of 2, which is 10 on the square root of 2. Minus, I'm going to go ahead and do just a faint separation between these. Now 80, well, that's 8 and 10, which is 2 and 5, 4 and 2, 2 and 2. I've got a pair of 2's, a pair of 2's, and a 5 left over. Actually, I'm going to go ahead and spread this out just a little bit. Eight and 10, which is 2 and 5, which is 4 and 2, 2 and 2. Pair of 2's, pair of 2's, 5 left over. So that gives me 2 times 2 on the square root of 5, which is 4 on the square root of 5. Let's go ahead and do this. I'm going to rewrite it over here. Well, 125, well, I know that's 5 and something. So let's think. We can get our calculators out. We do 125 divided by 5 in our calculator. we get that the answer is 25. Which of course breaks down into 5 and 5. We've got a pair of 5s, the 5 left over. Which brings the 3 times the 5 on the square root of 5. 3, 5 on the square root of 5. Which becomes 15 on the square root of 5. So now everything's been simplified. Let's take a look. Well, that's square root of 2, square root of 5, square root of 5. Which means that these two are equal. Well, not they're equal, but they've got the same index and the same radicans. They are like. They're similar. So I can combine those. Well, the 10 on the square root of 2 doesn't change. Negative 4 plus 15 makes plus 11 on the square root of 5. And that is as much as we can simplify this. These will not combine anymore because the radicands are different. All right, let's go ahead and take a look at number 12. Well, my indexes are the same, but my radicands very different. Let's go ahead and break this 80 down. 8 and 10, 2 and 4, which is 2 and 2, which is 2 and 5. Pair of 2's, pair of 2's, 5 is alone. This 5 is alone. So we got the 12. Oh, hold up. I almost made a big mistake. This is index of 4, so we're not looking for groups of 2. We're looking for a group of 4. Well, there happen to be 4 2's. So a single 2 comes out. And then 4th root of 5 plus 18, 4th root of 5. Make sure you pay attention to your indexes because we don't want to make the mistake that I almost made right here. Well, 12 times 2 makes 24 on the 4th root of 5 plus 18 on the 4th root of 5. Well, same indexes, same radicands. 24 plus 18 gives us 42 on the 4th root of 5. Again, I broke down the 80 as a 4th root, so I looked for a group of 4 combined. Notice that these were the same and combined again. Let's go ahead and take a look at number 10. These are cube roots, but these don't look anything the same, so let's go ahead and break them down. Well, 16 I know is 4 and 4. So that's 2, 2, 2, and 2. Index is 3, so I'm looking for groups of 3. This is 2 and the square root of 2. All right, well, let's take a look at 54. Well, I know I can divide that by 2 because it's even. And so 54 divided by 2 is 27. Well, 27 is 9 and 3, which is 3 and 3. So I've got a group of 3's. This is only 2. I just boxed this 2 that I forgot to box already. This is only 2. This becomes 3. And these are not square roots, they're cube roots. And I'm adding. Well, indexes are the same. Now the radicands are the same, so I can combine. 2 plus 3 makes 5 on the cube root of 2. So now we've just worked through 4 problems of adding and subtracting radicals. So that's what this unit is about. This lesson is about. It's about dividing radicals and then being able to add and subtract radicals. So, good luck on your assignment. Hope that you have a good day.